Right, so thank you very much indeed. As I said, it's a pleasure to speak to you this evening. So my name is Andrew Chadwick. I'm with it's a long title, but I work with the Connected Places Catapult, but I'm also, Steve mentioned, I'm also the chair of the Royal Aeronautical Society's Unmanned Air Systems Specialist Group Committee, and also for the topic of tonight's lecture on the Drones Pathfinder Programme, I'm also on the steering group of the Pathfinder itself. So, kind of a fun-packed evening, as it were. So, the UK Drones Pathfinder Programme is a programme which is sponsored by the Department for Transport. It's a programme that's been running now for about 3 years, and we've been involved. In fact, the Connected Places Catapult is responsible for the delivery of the programme itself. Before I get into the details of the programme, I'd like to give you a little bit of background about the Connected Places Catapult and where we sit within the UK Research and Technology Organisation in the UK, and then we'll start talking a little bit about the drone industry and then into the Pathfinder programme itself. So the Connected Places Catapult is one of 9 innovation centres around the UK. So this is a network of world-leading centres which are designed to transform and also to accelerate the UK's capability for innovation and future economic growth. So these vary from the Connected Places Catapult, so the digital catapult, satellite applications, high-value manufacturing, energy systems, and a variety of others as well. And I said these are located throughout the UK, and we generally work closely together on a number of programmes, and also with other stakeholders, both in government, industry, and with academia as well. The Connected Places Catapult is the UK's innovation accelerator for cities, transport, and place. So our focus is in those specific aspects. So we're an independent, neutral, and trusted convener. So we operate between public and private sectors, between local and central government, and also addressing today's and also tomorrow's challenges. So it sounds very grand. So our focus is on connecting businesses so that in order we can generate new opportunities and also accelerate the creation of innovative products and services so we can deliver solutions and also increase UK growth and benefits to UK as itself. So at a glance, we work across a number of domains, from the built environment, well-being, public spaces, critical infrastructure, and also mobility. We tackle a number of market barriers and failures, and we have a 3-pronged approach to these challenges. Of most important to me in particular is our work with businesses and also with research institutions and academics. So we have an SME, so a small medium enterprise network, where we have over 3,500 SMEs signed up to the Catapult, where they receive notification of potential opportunities, both inside the Catapult and also external opportunities, business opportunities. They provide business advice and help, and also connectivity, some of the events and networking events that we have within the Catapult. Similarly, we have a academic network, and within that we have I think about 300 or 400 academics signed up to that. And again, we use this for 2 reasons. One is that we can share a lot of the information that we have and also make business opportunities available to academics and to universities, but also we use it as an opportunity to dip into that pool of academics to get latest thinking. And we sometimes ask our academic support to support some of the workshops we have with some of our clients, with government and with others to support our work. So it's a very important part of what we do within the Catapult is to bring together businesses, research institutions, academics, and also with government, both local and central. And so our activities take 3 forms. So we provide physical and digital platforms, so we can actually facilitate engagement. We can showcase UK businesses and capabilities, and we do that both in a UK and a global scale. And we can coordinate the market around recognised roadmaps. So we do a lot of road mapping, both on the technology, the business, and also more and more so on the sustainable and the aspects of, in my case, in aviation, but right across the board for what we do within the Catapult. And from that, we can generate a lot of market intelligence, thought leadership, and analysis, which helps inform our business, but also inform some of the products, prototypes, services, and also influencing R&D investment, both within the Catapult and across Innovate UK and other organisations. And we finally, we participate in a number of projects. We can either lead those projects or we work with a number of organisations and collaborate on a number of projects right across the board. And our three main areas of focus for strategic focus are levelling up to the regional productivity aspects of government policy. We're accelerating the transition to net zero, and a lot of the work we're doing, particularly on aviation and some of the work we're going to talk about today around that, and also restarting and the recovery from the post-pandemic. And we've been supporting a number of government departments on that in the last 14 months or so. So moving on to drones or unmanned aircraft system, it's always a bone of contention is what do we call these things? So in the context of the Drone Pathfinder Programme, the word drone is another term for an unmanned aircraft. So unmanned aircraft, as you'd expect, come in a variety of shapes and sizes, ranging from the small handheld types up to much larger aircraft. And they have a variety of configurations, so they could be fixed wing, rotary wing, or even a combination of both. There's a number of other definitions, so drones, remotely piloted aircraft systems, which tends to be more of a military term. We have unmanned air vehicles and unmanned aircraft systems, and I'm sure there's others as well. One thing they do have, though, is they share the common characteristic that the person responsible for piloting the aircraft is not on board. So, but just like any other aircraft, an unmanned aircraft must always be flown in a safe manner, both with respect to other aircraft in the air and also to people and properties on the ground. And I think that's very important to recognise and also to make that point, because we find that there's a variety of opinions about drone pilots, drone operators, but on the whole, the majority of them do operate within the law, and we'll talk about that later on as well. So the background to the drone market. So why are we actually doing this program, and why is there such an interest in it? So according to PricewaterhouseCoopers in 2018, they had a report that details the sources at the bottom of the slide there. The impact of drones in the UK by 2030 could be up to a £42 billion increase to the UK GDP. That would represent £16 billion in net cost savings to the economy, and also anticipated over 600,000 jobs in the drones economy. The economy not just being the operating of the drones, but also the activities associated with the design, the maintenance, but also the activities associated with the data and the information which is collected by the drones. So the rising use of drones in business and public services should be highly impactful from this report, and it delivers significant benefits for the UK economy and also for society. However, as you'd expect, the UK has a narrow window of opportunity to be at the forefront of the global drone industry, and the 2018 report suggested that we needed to act now. The tables attached to this, I won't go into too much detail on this, but really this gives an indication across a wide variety of sectors of the type of gross cost savings from drones, if utilising drones, the cost savings, and also a multi-factor productivity impact. What's interesting here is that we're seeing the technology, media, and telecommunications seem to be the largest growing sector in there. But this particular report has been used as the basis for a lot of companies for where they're looking to develop their business and also some of the services that are being provided. A little bit more background. The report from PwC had predicted that there will be about 76,000 drones flying in the UK by 2030. That's not all at the same time. That's actually across the board, and that's a mixture of both recreational and also professional drones. In comparison to other air users, I thought it'd be quite interesting just to do a comparison. So for GA pilots, It's anticipated there'll be 10,000 by that timescales, just over 2,000 glider pilots, 1,500 helicopter pilots, 1,500 balloon pilots, and around about 4,000 microlight pilots as well. So it's quite interesting that potentially the UK drone population could be the highest stakeholder in aviation. But there are challenges, as you'd expect. So manned aviation has developed rules and processes over the last 100 years. And airworthiness certification and procedures assure the vehicle integrity. And obviously obviously and continual training for pilots is required to prepare them for normal and emergency services. And regulators do oversee a highly organized infrastructure with procedures and routes so we can assure safe flight. So in order to safely integrate drones, all these aspects and others need to be re-examined. In particular, the key areas that need to be addressed before drones can fly safely around our skies. So we are working, as I mentioned at the beginning, with the Department for Transport, with the Civil Aviation Authority and with industry to work out how drones can be safely integrated into the airspace. So drone users and operators need to prove that flying drones is safe. In particular, and a lot of the work we're looking at is operating beyond visual line of sight. So this is the long distance, beyond 500 meters distance operating, because that is believed, particularly within the reports, like the PwC report, that being able to break that barrier, being able to operate beyond visual line of sight safely would actually open this market up dramatically. And so it's the interoperability between drones flying at those distances and all other air users is something that we need to look at and address. And also to create the procedures and the technology so we can integrate those drones into the airspace. And so there's a number of systems and programs around unmanned traffic management. And in fact, I'm going to talk about one of those projects that we're leading on shortly. So there's a few things key areas that we do need to address. So it's not just a simple case of these systems flying. We need to ensure that we integrate safely with the airspace and with all other air users, and vice versa. The ecosystem of unmanned aviation also is slightly more complex than some would believe. So it covers everything from the platform technologies, from the market sector, airspace issues, and also the regulatory side of things. And I've listed there a few examples of some of the aspects within each. One thing particularly interesting is the drone market, or the UAS market section there. A lot of these systems which are not being flown for recreation are being flown for business. So they are actually flown for a specific reason, and that may be under contract to actually deliver a specific product or a service. So one thing with a lot of unmanned aviation, which is not necessarily taken into account for other aviation stakeholders, is the fact that a lot of these companies actually need to or develop use cases and business cases for their operations, and they're actually operating within those cases themselves. So it's a means to an end, and these are operating tools that are used for their business. But across airspace issues, apart from unmanned traffic management, we have things such as collision avoidance, the rules of the air, which are the same rules of the air as manned aviation, surveillance and tracking. And obviously on the regulatory side of things, we have everything from the safety standards, certification, of which we're still waiting for certification standards to come along, but also the supporting ground infrastructure, pilot competencies, which have been defined, autonomy, and also public perception. So examples of how drone technology can be used across a broad range of sectors. You'd be pleased to know I'm not going to read the table, but the sectors variety, I mean, it's as wide as anyone can think of, really, but main ones we're finding currently are areas such as agriculture, energy infrastructure, of which we have a program which I'll talk about shortly, public safety, surveillance and security, so first responders and the fire service, transport and logistics, construction, and also insurance. These seem to be the main industry sectors, which interestingly were picked up in the PwC and subsequent reports. And what we're finding currently is that is the way as well. Also included in that could be the media industry, where up to 90% of aerial shots these days, both in TV and also in film, is captured using drones as opposed to manned aviation. But moving on to the Drones Pathfinder Programme. So this programme, as I said, was set up 3 years ago, and it aims to rapidly drive progress in unmanned aviation technology and regulation. And it's to enable industry and also the public sector to fully exploit the market in different industry sectors. So the Pathfinders take a phased approach so we can achieve routine use of drones within the UK, and we identify or focus on identifying and overcoming the technical, operational, and also the commercial barriers for bringing new BVLOS, so beyond visual line of sight, drone-based services to market in the UK. So part of the role of the Pathfinder is actually to identify what these barriers are, and to put together programs of work and companies who would to actually put together demonstration programs can actually demonstrate how we can overcome some of these barriers, and then to share those findings with the rest of the industry. So we articulate the challenges faced in bringing a new beyond visual line of sight drone-based service to the market in the UK. We are promoting the routine beyond visual line of sight operations in unsegregated airspace. We're looking at cross-cutting capabilities, so not just the aircraft itself, but also the supporting business aspects of it. And most importantly of all, we're ensuring safe, secure, and also sustainable operations, both from an environmental and also from a business perspective. So this work project is intended to look at all those areas. So the Pathfinders for last year and this year, we had 6, a couple of which have just finished, and I have some example slides coming up. So they're quite a variety. So one of them is, which I'll be talking about shortly, is looking at local beyond visual line of sight operations in controlled environments. So that's actually using a control station, which might not necessarily be on the site where the drones are being operated. So it's long distance control of drones. There's Above and Beyond, which is with the Energy Innovation Centre, which is ongoing. We have a program which has just started, which is looking at airspace integration of drones in response to COVID-19. Some of you may be aware and may have seen in the press over the last year the increasing use of drones for medical deliveries. This has been very successful, and has proven the technology beyond a lot of the company's dreams, I think. Recent trials and demonstrations up in the north of Scotland have actually identified terrific savings in terms of cost, but also in time, and also getting treatment to patients, and that's been proven. And we're hoping with the program we're having down in the Goodwood area with Trax International, we'll actually look at how we can actually integrate further into the airspace to achieve the same outcomes. We have a program which is being led by Cranfield University, which is looking at drones to detect marine ingress near nuclear power stations. We have a project which finished in 2019 looking at infrastructure inspection, and a project that finished at the end of last year with the Maritime and Coast Guard Agency, which is a drone demonstration and development, which was leading into and developing the requirements for the next stage of search and rescue helicopters and also supporting services. So I've got a few slides now, just giving a little bit more background in some of those programs. So one of our longest projects is the Energy Pathfinder, which we've called Above and Beyond. And the objective of this is to have the beyond line of sight linear infrastructure surveys across both the electricity and also the gas networks. So we're working with the Energy Innovation Centre and a number of electricity and gas operators, including National Grid, Northern Power Grid, and Cadent and Wales and West, to look at how these systems can be used to do that. So the Catapult, we actually brought the consortium together, or the Pathfinder programme did under the leadership of the Catapult. We successfully tested 4 different concepts of operations, and the intent is to perform some more this year. And we also created standardised operations for the maintenance of critical infrastructure for UK gas and electricity networks. And finally, with this project, we worked very closely with the Civil Aviation Authority and with stakeholders to help enable routine commercial BVLOS capabilities on network assets. the intent of which is to complement the work which is currently performed by engineers using a mixture of tools and having to climb up some of these structures. But we felt that the use of drones would actually be a lot more safer, and we've been proven in some of the concepts of operations that it certainly is, and we can actually collect a lot more data and information and imagery than we can do using the engineers who typically would do that. So that program is continuing this year, and we have a number of demonstrations and further proving flights coming up. The project I mentioned earlier, which finished about a year ago actually, but is it still relevant, is a project which was led by a company called Sensat. Sensat are not an aviation company. Sensat collect, manage, and manipulate and sell data and data services. So this was an interesting project. It was being led by a non-aviation company. And it was looking at beyond visual line of sight capabilities so we could reduce delivery and also operational costs in a construction project. And it was around the A14 up. Unfortunately, I can't read the slide, but it was on the A14. So there's a lot of achievements from this. So we succeeded in getting a regular approved beyond visual line of sight methodology and operational safety case. We gained a deeper understanding of drone beyond visual line of sight feasibility and the challenges, particularly in the context of road infrastructure inspection in the UK. And also we strengthened our relationships with the CAA, because one of the things that comes from this project is not just learnings that can be adopted or adapted by the industry, but it's also for the regulator as well. So we do a number of programs which have the involvement of the regulator, and we can actually help them learn more about this technology, what the art of the possible is, and also what the need will be for current and future regulation. So we're very lucky that and grateful that we have this relationship and the support from the CAA to our project. A current project we have is with a company called Seize AI. Again, these are not an aviation company. This is a company that actually collects, controls, manipulates in a good way data and sells that information on to the clients. But the objective of this particular project is to use a control room. So this is control room for basing their operations, so to introduce economies of scale. So effectively to be able to operate swarms or multiple drones over multiple sites. So they can economy of scale of scope and learning, and also enabling the delivery of more services at a higher quality, and also it's anticipated 10 times lower the cost. So as I said, the intent of this is to operate drones in a variety of different industrial settings, but have a number of them over a number of different sites, but controlled from one control room. So this will enable the remote operation of complex, close quarter missions in industrial environments using precise 3D remote operation. So that will be resistant to the loss of GPS or GNSS, loss of communications, and also electronic interference. It will design and build a system suitable for testing in controlled environments, and that's both urban and industrial. And it will look to develop advanced autonomy. So drones will be using their own LiDAR, cameras, and navigation sensors to build their own 3D map of the operating environment, and they'll be doing that in real time. The drones will then use this information for their own autonomous avoidance and also 3D path planning, with all that processing being performed on board and in real time. So it's quite an advanced technology, and we're looking forward to that. We've had some initial demonstration flights towards the end of last year, which were very successful, and we're looking more flying in the next month or so. The other one I wanted to talk to you about, the other project, is one which is just recently completed, which we're delighted with, which is with the Maritime and Coast Guard Agency. And this is a search and rescue pathfinder. And the objective of this project was to work with the regulator to identify a route for the Maritime and Coast Guard Agency for routine and regular use of drones in unsegregated space, and also to demonstrate against specific MCA time-critical use cases. So the idea of this project was actually to demonstrate the use of drones in real-time, realistic search conditions. And it was quite a very positive and very successful project. So it achieved beyond visual line of sight operations with a certified drone in controlled and uncontrolled airspace. And you can see it's a larger system, this one. I think it's about 180 kilos, maybe slightly more. It was the first unsegregated flight in controlled airspace to depart from and arrive into the UK and fly internationally. We've put it internationally into inverted commas because it was Ireland, so we were flying over the Irish Sea. It also was an ADS-B trial, which proved the utility of drones' BVLOS operations, and also how that would integrate with manned aircraft within the MCA fleet. It achieved engagement with the regulator and took them on a journey with the project, and it was key and successful. The idea of this was to inform and I think educate the regulator and others on the potential use and perceived use of these drones for future search and rescue operations, and also the direction that MCA would like this to go and where regulation needed to be fit for purpose for what they were trying to achieve. It did prove to increase the effectiveness of search. It reduced risk to personnel on both land, sea, and also in the air, and time as well. And it decreased the reliance on traditional rescue assets to perform a search. So rather than having helicopters flying around for many hours searching, it was possible to use the drone with the sensors on board to actually cut down those timescales quite considerably, and to be able to integrate with the helicopter for the research, for the search aspects of the operation itself. So both manned and unmanned working together. So moving on from the Pathfinder program, we've now moved into this stage, the next stage of the project, which is we're rebranding it as the Pathfinder Catalyst Programme. And the intent with this project for this year and going into next year is to increase the impact of the project at pace. So it's taking all the good work that we've done, all the sharings of lessons learned, all the working with other companies, the networking opportunities and everything else we've had to actually increase the impact of drone operations. So it's looking at actually building the market and focusing on those near-term commercially viable use cases. So there's greater and more focused engagement with government, with local authorities, with businesses and investors. And that's not just the drone industry, but more particularly, it's the end users and the people who may adopt drone technology for their businesses to increase their efficiencies within their businesses and also the amount of service available. There's also a focused public engagement activity. And also we're going to continue sharing the evidence and the learnings through demonstrations in real world environments and also through presentation and sharing of materials. So not only are we going to develop and identify new use cases and ways for using these systems both on a local, a national level, but also within specific sectors, we're actually going to do specific demonstrations around that so we can actually demonstrate that the positive impact that drones can bring to companies and their businesses. And also the plan is to tackle some of the key remaining unmanned technical challenges. So it's quite an ambitious piece of work. So the real-world demonstrations I mentioned will bring to life the benefits of drone solutions, and we have a number of planned, including flying with the housing associations, with the energy systems, with Highways England, Network Rail, and a number of other organisations around their networks and infrastructure, and also with other users in the agricultural use as well. And so we're looking at case studies and economic analysis for each demonstration. So we're not just flying just to show that you can actually fly these things in certain scenarios. It's also to have a supporting economic case that will back up that use. And finally, as I mentioned, we're having research and engagement program to understand public view of drones in the UK in 2021, and also to address public acceptance. And so we have a program of work, and we've subcontracted a social research company to do that work on our behalf. So it's quite a detailed program of work, taking forward the work that we've already done in the Drone Pathfinder program. So all those example projects I spoke about earlier, but taking them to the next stage and doing some real world demonstrations for companies, for industries, but also for local authorities and also regional governments as well. And the other aspect is enabling innovation. So we currently have a competition. We're in the awarding stage where we have 6 grants of £30,000 for ambitious projects which align to 3 themes that we've identified. So we had a call, I think it was about 6 weeks ago now, where we were looking for potential research projects looking at onboard detect and avoid. So there's how equipments that would be flown onboard a drone which would detect and avoid other air users, but also other um, aspects such as ground infrastructure and also weather. We also had a theme around autonomy, the increased use of autonomy on drones, and also around communication and navigation. Within the Drone Pathfinder projects as well, what we were looking at and what we provide to these programs is not only just the finance for the companies who will be notified in the coming weeks, but also we provide additional technical support, engagement with the Civil Aviation Authority, and also market exploitation and business advice. So not only will we doing these projects, not necessarily flying, but looking at some of the technologies, but it's also that additional business support. So we can actually grow and help support some of the SMEs that have bid for this work. And we're really looking forward to that. As I said, there should be an announcement with that in the coming weeks. So that's the Drone Pathfinder Programme. It's quite a detailed programme, a lot of work that we're doing and will be doing this year. So looking at how we can introduce more drones into industry, into business, and promote the safe adoption of drones within industry. But in order to achieve some of this, there is a need to have a digital framework in which drones can operate. And I mentioned earlier the unmanned traffic management. So this is a system that enables unmanned aircraft to fly in the airspace. And we have a project, a piece of work, which I'm going to talk about now, which is called the Open Access UTM Framework, which is a piece of work which the Connected Places Catapult is performing on behalf of the Department for Transport. So why do we need UTM, or unmanned traffic management? Well, as I mentioned a few slides back, there will be a significant increase in the volume of drones that will become increasingly more autonomous and flying beyond visual line of sight of the remote pilot. So there'll be a need for a scalable digital air traffic management system that can monitor and also manage drone operations, and to keep them safely separated using services such as deconfliction and also restricting access to volumes of airspace. I think what's important here to highlight is the fact that this is a digital air traffic management system, and what we're hoping to achieve by this, and some of the feedback we've had from ANSP, so the air navigation service providers, not just in the UK but globally, is the recognition of the increase of the potential of using digital air traffic management systems and services right across the board. So in some ways, we see the introduction of UTM systems for drones as really a dry run for right across the rest of aviation. So the background to the project itself. So the Open Access UTM framework, as I mentioned, is sponsored by the Department for Transport, and it's developed in partnership with industry. The intent is to build a UTM framework to simulate that framework and also to test in real time with real drones and real UTM systems. And its goals are to inform the Department for Transport of UTM and also to determine the next steps for technology and regulation. It's to convene industry and subject matter experts to help develop a national UTM system and also develop the methods and approaches and service requirements for that UTM systems. And from that, building a consensus and provide the UK industry an opportunity to feedback the work that we're doing and gain an understanding of how UTM works in practice. And to enable that impact, and as with everything we do within the Catapult, is to share the specifications and all the learnings from the project itself. So the Open Access UTM Architecture and Services is a federated architecture of interconnected services providing a range of different entities. So that would range from the regulator itself, public authorities, we have the air traffic management services, airports and airfields and drone ports, but also the UTM service provider, of which there may be many, and also data service provider and license operators. And the projects that we've almost completed now demonstrated the following core services, and that was from registration, from strategic deconfliction, monitoring and alerting, in-flight replanning, dynamic constraint, and also remote identification. In addition to all of this, we also implemented an enabling service known as Discovery and Synchronization Service. So this is the sharing of data and information and aircraft positioning across a number of different service providers. So rather than having one service provider controlling all the information, and we actually share that information through the DSS service. And that was demonstrated recently. So the project started in 2019. And the activities, there was a number of which, and we're supported by the companies listed on the slide there. So from Altitude Angel, who's a UK UTM provider, the Civil Aviation Authority, with NATS, with Thales, with the Satellite Applications Catapult, with Cranfield University, ANRA Technologies, and RAeS, who are part of GE Aviation. And during that time, we developed the concept of operations for that framework. We developed the use cases and the scenarios that can be used to assess the system, and also the details of the architectural components, the services, and also the communication framework, and investigated the regulatory developments to support unmanned traffic management. We also identified and addressed the UTM capability gaps by recommending a number of solutions from other initiatives, such as the ATM modernization strategy. And also we built consensus on future direction and timescales to inform the UTM roadmap. And one thing to make clear on this project in particular is that this was not a standalone project. As you'll see, we have the Civil Aviation Authority and NATS, who are the UK leading ANSP, involved in this project. We wanted to make sure that we actually addressed all the issues regarding integrating drones into the overall airspace management system as well. And we wanted to make sure that was safe and that the systems could be managed both by NATS and by other organizations. And so it was important that we had those organizations support the project, particularly in the early days. The number of deliverables, you'll be pleased to know I'm not going to read both the reports to you, but we've had 2 reports to date, one of which was released in May 2019, which was detailing or preparing the initial groundwork, which was looking at what a UTM system was, what the procedures and processes were, and the work that we achieved in that. And there was a following-on piece of work last April, which was actually, again, reporting on all the work that we'd performed, detailing the processes, the procedures, the protocols, and the network and the architecture that had been developed during the project. As I said, the nature of this project and a lot of the work that we do in the catapults is to share all the findings with all the industry so that everybody can take a share and take advantage of the good work that we and our partners perform. So the program for last year into this year, the intent was to have some more detailed system development. So looking at design specification and requirements, the software and system development, scenario development, and a number of sprints and cross-team simulations, so that we could have at the end of last year, so early November rather, we actually had a virtual demonstration, so in a simulated environment. And then there was a period of trials planning, which was completed in February, March time, where we actually performed some actual field trials. And these were performed in the UK with flying drones and with UTM systems operating together, handing control between each of the other. And because of the nature of COVID, the companies that were involved were based in the UK and in the US. So actually we proved that UTM could work whether you were actually within the country or outside of the country itself, as it's a digital system. The companies involved are listed below rather. So Altitude Angel remained with us, as did ANRA Technologies. GE Aviation were here for a short period of time. And then Collins Aerospace supported us, and Wing. And we had a drone operator called Skylift also supporting the project itself. So during the demonstration phase, we demonstrated a number of UTM services across some real-world scenarios. And so the three we particularly concentrated on were drone delivery. So we were looking at strategic deconfliction and also in-flight replanning to enable multiple and complex proximate operations. We did an emergency service response demonstration, so a number of different operations which were coordinated, or each of the service operators were coordinated their responses to an emergency services drone flight. And also a wind farm inspection, where we did a remote identification of drones and how UTM services respond when an operation deviates from its approved flight plan, and how this is communicated across service providers and also to other operators. So we were testing the system and how that worked, and also how it worked with other air users and how that was communicated. So we achieved, just finalizing our report now, our final report, but there's a number of achievements which I've listed here. So this was a UK first in demonstrating interoperability of multiple UTM service providers. We proved the concept of a federated architecture for unmanned traffic management, and we demonstrated the availability of existing technology which is capable of implementing UTM standards. We provided, and it will be published, the evidence base to inform the development of UTM policy and regulations, in particular in the UK. And also we identified and showed that investment within open access UTM could be exploited by other programs. So for example, the Future Flight Challenge program, which I think was mentioned in the AGM earlier. We identified an approach for testing and also for certifying new open access UTM services and providers were required. And finally, from a Catapult perspective, we were delighted that we developed the capability to manage large-scale, complex field trials on an international basis, which we didn't actually expect, but always good to see. So that's UTM, and that's also the Catapult's Drone Pathfinder Programme. But finally, just before I finish, it's important to know that people don't just fly drones for the sake of it. There are rules and regulations, and from last month, if you fly or own a drone or model aircraft, you must register with the CAA before you fly. And the details are at that website. This is for any drone larger than 250 grams. So every owner and operator of drones in the UK has to register. And there is a test. It's an online test, and it's not the most difficult test, but there's a test. And then there'll be a registration number assigned to you as a user and an identification. In support of that, there is also a drone safe and there's the drone code. So it's important, if we're using these systems, we have to demonstrate them safely and operate them safely, maintaining distances from people, from critical national infrastructure, particularly airports, and also away from buildings. And the slide there gives you some examples of some of the rules that we abide by. We've been abiding by these for some time, but now they are now in law. So I'm really pleased to say that the Drone Pathfinder Programme is moving on. It's very successful. We're looking forward to this coming year with the demonstrations and more engagement across the industries within different sectors and also with the public. Further details can be provided and found at the webpage, which is provided there. So you can get access to all the programme project information, upcoming events, and also past presentations. So you have access to all the previous presentations and all the details of all the work that we've done, all the projects we've done, and also linking to the UTM programme. And you can also email us at drones@cp.catapult.org.uk if you have any further questions or you need any more help or information, because we're here to help. But I'm really grateful for the opportunity to speak to you this evening, and I'm happy to take your questions. Thank you.
Thank you, Andrew. So if people would like to raise their hand, and we'll take the questions. But the first one's from Ray Wilkinson.
Hi, Andrew. Thanks for the presentation. It was very, very useful and informative.
Thank you.
My question is about electronic conspicuity, which the CAA are pushing very hard at the moment. The problem is there are 3 systems that I know of, and probably some that I don't, you know, with the exception of looking out the window, which some pilots do and some don't. They're not compatible with each other. So we have FLARM, we have ADS-B, and we have pilot aware. Are you proposing that in order to allow drones to mix with other air traffic that there'll be yet another system?
No.
Good.
No, thank you. No, it is a bit of a quandary, isn't it, Ray? I think there are a number of different systems, and what we're trying to do in the drone instrument in particular is to find and perhaps to help to find a consistent solution between all of those that are out there. I mean, each of them has their own merits, and there are ways in which they can be integrated together. In fact, I know a number of professional drone operators actually have all those systems you've mentioned on their systems themselves operating, so that they can be seen by other air users. But you're right, there are so many different conflicting stories, ideas, and standards for these. And part of the work we're looking to do through the UTM project, and more importantly through the Pathfinder, is to work with the Civil Aviation Authority, with other airspace users. So we engage with the GA community, not just the drone services providers, to find a way through that and to see what is the best way to operate these and how we can integrate them. So there's a lot of work that goes on. I could name a few drone systems as well. Drone Assist is a very good one, which drone pilots use, which shows you where you can't fly in the UK. But it's how we actually integrate those together, and it's something which is being looked at. I don't have unfortunately I don't have the answer for you, Ray. I can't say, oh yes, the answer is this, but we recognise it, and I know drone service companies are aware of it, and a lot do use a variety of different services. In fact, the project I mentioned, which we're doing down in Goodwood, looking at the airspace integration on the back of a COVID-19 program, is looking at how we can integrate those different electronic conspicuity systems together.
Okay, thank you.
Keith?
Andrew, thank you very much. From your point of view, have you seen a particular emergency service taking an interest in drone operations?
I have. In fact, I've flown some drones for the emergency services. We're finding a lot of interest from the fire and rescue services, who are using them on a local level to a way of keeping their crews away from fires, and also so they can look at perhaps some of those fires which are like in chimney stacks and like, so those that are quite dangerous to access. And also the police are using them for a certain extent, particularly around searching for missing people. There's a lot of work around that, which I know is taking place. There's been some demonstration and trials. Some have been in the press for some of the wrong reasons, but a lot has been centered around the use of drones by the police for search of missing individuals. So that's happening more and more, and I know a lot of lessons are being learnt and shared between the forces, both in the fire and rescue services and in the police, on the use of these systems, and being operated by approved pilots. So a number of these personnel, both in the fire and rescue service and the police, are approved pilots from the CAA. So yes, there's lots of evidence of them being used and being used safely and successfully.
Thank you.
John Mills, I think you have a question.
Yes, John Mills of E2E Services. Andrew, what interactions you had with Ofcom for radio spectrum, given a lot of these drones are very dependent on radio communications to control them?
Yes, they are. It's funny you should say that, John. So we're doing a lot of work. For those, you might be aware that drones do not have dedicated operating frequency. Typically, there's a number of frequencies, particularly around 2.6 gigahertz, where they operate. And for using drones, drone operators need to apply for a trials license. So there's no continuous service license available. You have to apply for trials license. So we are working with Ofcom through the Catapult and working with industry and the CAA and others to try and find a way forward on how we can make that easier. How mobile network operators, so BT, Vodafone, EE, network providers like that, who are being approached more and more by drone operators on how they can use and provide that service. So maybe provide SIM cards specifically for drones, but ensuring that they work within approved operating frequencies. And some of that work also looks at potentially geofencing. So maybe geofencing specific areas where that's critical national infrastructure, such as airports or other areas, such as radio astronomy sites, so that drones cannot fly in those areas or interfere with what's going on there. So there's a lot of work which is taking place, a lot of work, a lot of meetings, a lot of discussions, all positive between the industry and with Ofcom, who are being very open to this. There's a lot of work which is taking place, not just in the UK, but globally, looking at this issue. I think it's been recognised that we're not going to go away, and that it needs to be resolved. And the industry is very keen to work closely with Ofcom to make that happen. So it is recognised, and work is going on that, John.
Thank you.
Thank you.
I can't see any more questions.
Very, very thanks, Andrew. I thought that talk was most inspirational. I must admit, as someone who flies around the sky regularly, I'm relieved to see so much effort being put into avoiding mid-air collisions, and I'm sure Ray agrees with me. The idea of 76,000 drones around by 2030, thankfully, I won't have my license by then, I'm sure. Tempting fate though I am, the nearest I've come to a collision with a UAV was a passing hydrogen balloon. I remember seeing whizzing past with a label on it. Anyway, thank you again, and I'm sure we all wish the Pathfinder programme every success.
Thank you, Maurice. It's been an absolute pleasure, and it's nice to be in Hatfield again.
Great, thank you.